Why are the metric units of acceleration meters per second per second? We can rewrite this as meters per second divided by seconds, and then rearrange that as meters per second times 1 over seconds. This gives us meters per second squared, or meters per second each second. Example, suppose the initial velocity, or the velocity at time 0, is minus 2 meters per second. Remember, velocity is a vector, so the minus sign means that the motion is in the negative direction. The acceleration is plus 3 meters per second each second. What is the final velocity v sub f after t is 3 seconds? We do a table of values, time and final velocity. Velocity at time 0 is minus 2 meters per second. After 1 second, we've increased the velocity by 3 meters per second, or moving at 1 meter per second. After 2 seconds, add another 3, or 4 meters per second. After 3 seconds, add another 3. And so our final velocity after 3 seconds is plus 7 meters per second. Plus meaning that we are moving in the positive direction. Demonstration problem 1. Goober accelerates as you don't go from 60 kilometers per hour to 90 kilometers per hour in 4 seconds. What is his acceleration? Must be in standard units, or meters per second each second. Note that this is one-dimensional motion, or motion along the x-axis. This is the negative x-axis direction, and this is the positive x-axis direction. We're given that at time 0, the initial velocity, or the velocity at 0 seconds, is 60 kilometers per hour. At time 4 seconds, the final velocity, or the velocity at 4 seconds, is 90 kilometers per hour. We will be more successful in solving multi-step problems if we use a structured approach. One such approach is the GUESS method, where the G stands for what are the givens, the U is what are the unknowns, the E is what is the equation, the S is substitute in with units, and the other S is solve. Given, the initial velocity is 60 kilometers per hour, the final velocity is 90 kilometers per hour, time is 4 seconds. In the given section, we write numbers with units and we associate a symbol for each quantity. Unknown, what is the acceleration? Equation, the acceleration is the change in the velocity over the change in the time, or the final velocity minus the initial velocity divided by the time. Substituting in with units, 90 kilometers per hour minus 60 kilometers per hour divided by 4 seconds, we get 30 kilometers per hour over 4 seconds. Since we have written the units, we see that they are not consistent. We must have meters per second, or standard units. Therefore, we must convert 30 kilometers per hour into meters per second. We do that by multiplying by 1,000 and dividing by 3,600, and we get 8.333, carrying one extra significant figure, or 4 significant figures, since our givens are 3 significant figures. The acceleration is 8.333 meters per second divided by 4 seconds, or 2.08 meters per second, rounded to 3 significant figures. Demonstration problem 2. Gustav, driving at 3 meters per second, accelerates at a constant rate of 1.50 meters per second for 10 seconds. What is his new speed? Given, the initial velocity is 3 meters per second. The acceleration is 1.5 meters per second. The time is 10 seconds. The unknown, it asks for his new speed, which is the magnitude of the final velocity. So v sub f is what? Equation. We need to rearrange the acceleration formula to get the form output, where the output is the final velocity, is a function of the input. The input here is the time. We get the equation, the final velocity is the initial velocity plus the acceleration times the time. We write the equation, and then we substitute in with the units. Initial velocity is 3 meters per second. Acceleration 1.5 meters per second times 10 seconds. We get 18.0 meters per second, rounded to 3 significant figures accuracy, assuming that the 10 seconds is exact. No solving is necessary here because the formula is explicitly solved for the final velocity. Demonstration problem 3. Ludmilla is driving at 5 meters per second when she accelerates at a constant rate 2.5 meters per second to 90 kilometers per hour, which is 25 meters per second. How many seconds did it take for her to do this? Given, the initial velocity is 5 meters per second. The acceleration is 2.5 meters per second each second. The final velocity is 25 meters per second. The unknown, how many seconds did it take her to do this? That is, what is the time? The equation, final velocity is the initial velocity plus the acceleration times the time. Substitute in with units. 25 meters per second is 5 meters per second plus 2.5 meters per second each second times the time. Solve. 25 meters per second minus 5 meters per second is 2.5 meters per second each second times time, the unknown. The idea is to get all terms with the unknown on one side of the equal sign. In this case, this is just one term. And then we will divide both sides of the equation by the multiplier of the unknown to make it a 1. So here we get that the time is 20 meters per second divided by 2.5 meters per second each second, which is 8 seconds rounded to two significant figures.